Hi, this is Juan from JuanTutors.com. Welcome to my totally free office hours. Today we're working on the August 2016 New York Algebra 1 Common Core Regents Problem 1. If you want to access these exams, whether you're from New York or anywhere else in the world, you do not have to be a resident of New York. Just go to nysedregents.org, click on the appropriate tab, and all the past tests are freely available there. Here's the problem. The graph below shows the distance in miles, m, hiked from a camp in h hours. When I look at the graph, I look at the label, miles from 0 to 6, hours, h from 0 to 6, and I see the graph. It looks like an upside-down parabola. That's all I look at the graph for now. Which hourly interval had the greatest rate of change? I circled the word greatest, because it's a common mistake to look for the least rate of change when you're looking for the greatest. So hour 0 to hour 1, hour 1 to hour 2, hour 2 to hour 3, or hour 3 to hour 4. Okay, so I remember before I teach you exactly how to do it, I remember that rate of change means how quickly a function is changing. So if I look at the graph from hour 0 to hour 1, in fact, in the beginning of the graph, that looks like the greatest rate of change. That looks like it's changing the quickest, and later on, it's changing very slowly. So I'm going to guess in the beginning is going to be the greatest rate of change. Hour 0 to hour 1 seems to be the answer. So now that we do the problem as it actually is, they do expect us to know the definition. So rate of change, okay, is defined as delta y over delta x. Delta y means change in y over, and delta x means change in x. The delta means change in. So it's y, and it's calculated by doing y final minus y initial over x final minus x initial. Okay, so we'll go to choice 1 since we think that that's probably the answer. And notice that I'm going to write the formula again. I did an experiment with my class, and I found that the people who wrote the formula every time did it quicker. As crazy as it sounds, did it quicker, and of course did it more accurately. So I highly recommend that you write the formula every time. So hour 0 to hour 1 is here. This is initial and this is final. Final, so 2 miles is the final miles, minus initial miles is 0, over x final is 1 hour, minus x initial is 0 hours, is 2 over 1, which is equal to 2. So the rate of change in this case is 2 miles per hour. Okay? And from hour 1 to hour 2, that is a 2-hour interval, as a 1-hour interval as well. So I could actually compare by the number of miles that are changed. There's a change in 1.5 miles in 1 hour. So the rate of change is 1.5 over 1, which is 1.5. This is not greater than 2. From 2 to 3, the change is 1 mile in 1 hour. So the rate of change is 1 mile per hour. This is not greater than 2. And from hour 3 to hour 4, a half a mile in 1 hour. 1/2 over 1 is 1/2. This is also not greater than 2. So in fact, we were right. This is the correct answer. Now, here is a similar problem created by us. At this point, you should pause the video, try the problem on your own, and when you're finished, press play to see our solution. By the way, quick plug, the way we are providing these tutorials totally free is by having viewers like you see these videos. So if you like what you see, click the like button, subscribe, and let your school friends know that these videos are available. We're providing tutorials in algebra, geometry, algebra 2, trigonometry, bio, chem, physics, more coming. So look out for those. Here's the problem. The graph below shows the distance in miles, m, hiked from a camp in h hours. This graph should look familiar. We just look at it. Miles, 0 to 6, hours, 0 to h from 0 to 6, upside down parabola kind of a graph. Which hourly interval had the smallest rate of change? In this case, they want the smallest rate of change. Hour 0 to hour 3. From hour 0 to hour 3, okay, hour 1 to hour 3, hour 2 to hour 3, hour 2 to hour 5. Now I notice here that the time intervals change. They are under zero obligation to give you the time intervals be equal. They're under zero obligation to make the time intervals 1 hour long. And in fact, they're under no obligation to make the time interval an interval upon which the function is linear at all. This function is jagged, in fact, and that's okay because it's an average rate of change. The formula is still the same. Okay, equals delta y over delta x. Okay, so I look at hour 0 to hour 3. That looks like a big change from hour 0 to hour 3. So that I'm gonna skip that one for now. Hour 1 to hour 3 looks like it might be a little bit smaller, although it looks very similar. Hour 2 to hour 3 looks even smaller. Hour 2 to hour 5. I have a feeling that that's gonna be the answer. So I'm actually gonna start with choice 4. Okay. Choice 4, y final minus y initial over x final minus x initial, hour 2 to hour 5, here and here. Hour 5, the distance is 5 miles. Y initial is 3.5 miles. And x final is 5 hours. Minus x initial is 2 hours. So 5 minus 3.5 is 1.5 over 5 minus 2 is 3, which is equal to, in fact, 0.5, 1/2. Okay, so this is 1/2 or 0.5. So now let's see, hour 2 to hour 3. We calculated previously the rate of change is equal to 1. So this is not the smaller. Okay, hour 1 to hour 3. Let's see, that's a 2-hour change, but from hour 1 to hour 3, that's a 2.5 mile change. So we get y final minus y initial over x final minus x initial is equal to, let's see, 4.5 minus 2 over 4 hours minus 2 hours, which 4.5 minus 2 is 2.5 over 2 is 1.25, which is greater than 0.5 anyway. Okay, 1.25 is smaller, is greater. And from 0 to 3, that's a big change. 4.5 miles in 3 hours. Again, that's a greater than 1 mile change, so this is greater than 1. So there's no way that it's smaller than 0.5. So in fact, choice 4 is the answer. Okay, stay tuned for the next video starting right now. Thanks for watching.